All right, so this is the second class. We are going to study problems on the numbers. Okay, so I begin with prime numbers. So I list all the prime numbers less than 100, and I hope some of you can memorize all the numbers. Okay, those are prime numbers, so that will be, much easier for you to solve math problems for prime numbers less than 100. Okay. Well, if you are given prime numbers less than 100, then you probably can solve the following problem. Find an arithmetic sequence of 5 prime numbers less than 100. Now, let me recall the definition of an arithmetic sequence. A arithmetic sequence means a sequence of numbers, it's increased by the same number. For example, 3, 5, 7. This is an arithmetic sequence of 3 numbers. Okay, but the next one is 11, so you have to add 4 to 7 instead of 2. So this is not a solution to the problem. Okay, this is an arithmetic sequence. Is an arithmetic sequence of 3 primes. Okay, not 5. I just give an example. Yeah, 3 primes. Okay, so you have to go through all those numbers and try to find a sequence of 5 prime numbers, and the gap between the consecutive prime numbers is the same. Okay, so take a look at all those numbers. Can you find it? Okay, so here's what I found out. Okay, it's begin with 5, 11. Yeah, you can skip some of them. Okay, prime numbers. So 11 to 17, you add the 6, then add the 6, you get 23, right? Then you add the 6, you get 29. Okay, but then add the 6 will be, next one will be 35, which is not a prime number. So that's it. So this is a sequence of arithmetic. This is an arithmetic sequence of 5 prime numbers. Great. Okay, and I do wish you to memorize all those prime numbers. I hope. Okay, you first of all you count. Okay, how many of them there? Then you write down a piece of paper and practice. I hope you memorize all of them, because sometimes you have to solve the problem. You have to find out the larger prime numbers. Yeah, sometimes to satisfy certain conditions. Okay, then if you know all the prime numbers, then you can quickly solve it. Sometimes you're not sure 79 is a prime number or not, right? So now if you memorize it, it's a very quick one. Okay. Now the next topic is trying to find some rules we can check whether an integer is divisible by 3 or divisible by 9. Okay, we find out in order to check an integer is divisible by 3, all you needed to do is just add all the digits together, and that's usually a small number, then to see if it's divisible by 3 or not. Okay, now we needed to know why this is true. We have to give a proof. Okay, so here's a proof. Okay, we suppose I have a 3-digit number. I'll give you a 3-digit number. Okay, A, B, C. It's easy to check. Okay, so this is a 3-digit number. A, B, C are digits. Okay, A, B, C are digits. Then you add them. You can separate them because it's A is a 100th digit, so it's 100 times A. B is a 10th digit, so it's 10 times B, and C is just the units digit, right? So we want to prove if this 3-digit number is divisible by 3, if only if the sum of the 3 digits will be divisible by 3. So 100 is going to be 99, right, plus 1, right? And the 10 is going to be 9 plus 1. So now you can separate them, 99 times A plus A, right? And the 9 times B and plus B, right? And plus C. Now we're going to regroup them, okay? 99A plus 9B. And then you have the sum of the 3 digits, right? So clearly, this is divisible by 9. Of course, it's divisible by 3, right? If it's divisible by 9, of course, divisible by 3. So a 3-digit number is divisible by 3 or 9. You have to check the sum of the 3 digits. Okay, that's all. It's determined by the sum of 3 digits. So clearly, yeah, ABC is divisible by 3 or respectively by 9 if and only if A plus B plus C is divisible by 3 or respectively by 9. Okay, now in the middle school, when you get a formula, okay, you should think about how to prove it. Okay, sometimes you can, sometimes you cannot. Sometimes it requires more advanced mathematics, such as like area formula for the circle, right? How do we get this formula? How do we get the pi? It will be behind your knowledge to prove it. But like how to find the area formula for the triangle, you should be able to prove it. How to find the area formula for the parallelogram, you should be able to prove it. So when you see a fact like that, you can use it, but you should also know how to prove it. And so this is so once you prove it, you memorize, yeah, memorize it longer. Okay, so you can use it over and over again. You will never forget. So let's use above fact to solve the following problem. Okay. Find the digit D such that this 5-digit number 1, 2, 3, D5 is divisible by 3. Okay. Well, all you have to do is to check the sum of the 3 digits. So the sum of the 3 digits, right, is going to be 1 plus 2 plus 3 plus D plus 5. We want to make sure it's divisible by 3, right? So it's easy to add them together. So here, that is going to be 11 plus D. Now 11 plus D. Now what is the largest possible value for this? Okay, so the largest possible value for this is going to be D is the largest possible value is 9. 11 plus 9. That is going to be 20, right? So this is a number is between 11 and 20, right? So how many integers between them are divisible by 20? Divisible by 9, by 3, okay? So 11 plus D should be equal to 12, 15. I think the next one is 18, right? So integers between 11 and 20 are divisible by 3, then there must be 12 or 15 or 18. So you're going to get 3 solutions. Okay, that'd be 1, right? Then that's 4. That is 4, and that is going to be 7. So there you find all the 3. I'll find, yeah. So this is a solution. You get 3 answers. The answer, the 3 numbers here. Yeah. So the solution will be not unique sometimes. Yeah, great. Our next problem is to prove 101 is a prime number. This is the first prime number greater than 100. Okay, I give you the hint here. If not, it must contain a prime fact P less than 11. You know why? So how do we prove this kind of statement in mathematics. Because if you're given 101, right, it's harder to check whether this is a prime number, you know, if you don't remember it, right? So what do we do? Okay. All right. So first of all, we assume, okay, here's a proof. Assume that, okay, we needed to learn how to prove things, okay, in mathematics. So how do you prove something? So you just say, we prove it. This is a so-called method proof by contradiction. Okay, you assume that this is it's not a prime number. So assume that PQ equals 101. Okay, and P is the smallest prime factor. Okay, P is smallest, so P should be less than equal to P, right? Equal to Q. So P is the smallest prime factor. Okay, so there are many prime factors there, right? So assume, and the Q is not necessarily you know, a prime number. Okay, just another. So assuming that the 101 is divisible by some small prime number. So what is that P? Okay, then P should be less than Q, right? So Q should be greater than P, greater than equal to P. So that means PQ, okay, is greater than equal to P times P. And that is P squared. It's 101. So if that is if 101 has a prime factor, that P cannot be larger than 11. Okay, so it must be equal to less than equal to 10 because 11 squared is already 121. So how many prime numbers there are less than 10? Well, there are not many. P could be 2, could be 3, right? 2, 3, right? And the 7, that's it. So those are the possible values for P. Okay, 2, 3, 7, right? And look at the list of all the prime numbers here, right? Right? All the prime numbers. 5, yeah, 5 is a prime number. Yeah, I'm missing the 5, right? 5, 3, no, that's 3. Yeah, 2, 3, 5, 7. So 5, yeah, 5, of course, it's 7. Yeah, so 5. Okay, so then you check each of them, and clearly it's not even number. So this P cannot be 2 because it's not even number, right? P cannot be 3 because the sum of the digits is not divided by 3. And P cannot be 5 just because it's not the 0, as the units digits is not going to be 0. And it's the units that is not 0 or 5. So now P cannot be 7. You have just all you have to do is check it, just 101 divided by 7. So P cannot be 7. So this is the only number you have to really do some computation. Okay, you really have to do some computation. So it's not divisible by 7. Now, in general, it's very hard to check whether a number is divisible by 7. Okay, in general, if you are given a very large number, how do you check whether a number is divisible by 7? Okay, there's no general rule here you can use. Maybe you can find out by yourself. Some not a very simple way to do, but it's still better than, you know, nothing, right? Okay, now we're going to check whether an integer is divisible by 11. We find out for 11, yes, we have a simple way to check whether it is divisible by 11, just using the digits. Its digits called alternating sum of its digits. That means you change the sign, okay? And you change the sign and yeah, and then add them together, okay? So I'm still using I'm still going to use a 3-digit number, okay? Check this with A, B, C. So it's 100A plus 10B plus C, okay? So I'm going to separate them. 100 can be still written as 99 plus 1. The reason I express 99 plus 1 because 99 is divisible by 11, okay? 10, okay, 10, I cannot change it to 9 plus 1 because 9 is not divisible by 11. I have to change 11 because then minus 1, okay? So now you have a 99a and plus a, 11b minus b plus c. Okay, I wish you to prove this. This is true for 4-digit number when you have a time. Okay, so it's 99a plus 11b, and here I have an alternating sum. You see, a positive, b is negative, c is positive, so it's alternating. Okay, so this is clearly divisible by 11. You know why? Because 99 is divisible by 11, 11 is divisible by 11. So a 3-digit number is divisible by 11 if only if this alternating sum is divisible by 11, right? Because the first part is divisible by 11. So ABC is divisible by 11 if and only if we just need to look at this alternating sum is divisible by 11. Okay. So using this fact, this is true for general, not only 3-digit number. I just gave you a proof, simple proof for this special case. Okay, so I want you to finish this problem. Okay, if you get answers, post to me privately. Don't post to everybody. Okay. All right, find the digit d such that the 5-digit integer, okay, 1, 2, 3, d5 is divisible by 11. Okay, so it's 12,300 something, right? D5 is divisible by 11. So let me know if you get the answers. Okay, Michael, do you have an answer? All right, so all I have to do is to find the alternating sum of this 5-digit integer. Okay, alternating sum is going to be, we can begin with 1, right? Positive, minus, positive, minus, positive. Okay, so it's alternating sum. So what is that? Okay, this is going to be, 1 minus 2 is -1, right? 3 plus 5 is 8. 8 minus 1 is 7. 7 minus d. Okay, 7 minus d. Okay, 7 minus d. We want to make sure it's divisible by 11. Now, do we have many solutions or not? Just only one solution. Okay, so let's look at the range. Okay, so this is always less than equal to 7, right? But greater than equal to the largest possible value is for d is 9. So 7 minus 9 is -2. So 7 minus d is always between -2 and 7. Now, integers between -2 and 7 divisible by 11, if only for 7 minus d is 0. Okay, so 7 minus d is divisible by 11 if and only if 7 minus d is 0. So that's why you get only one solution this time. So if and only if d equals 7. Okay, that's why how do we solve the problem. Okay, so sometimes you have several solutions, sometimes only have a unique solution, sometimes you have no solution. Okay, all right, so next one is about prime factorization. We're trying to factor 4,242. All right, and can you do that? All right. Of course, it's clearly it's divisible by 2, but I'm not going to do this way. 4242 because it's the same, right? So you can write 4200 plus 42. Then, yeah, it's going to be 42 times 100 plus 42. Then you take the common factor out, which is 42 times 100 plus 1 is 101. Now remember, 101 is a prime number, okay? So 42 it's easy to check, right? 42 is going to be 2 times 21. 21 is 3 times 7. So you get this prime factorization, right? So you get prime factorization. Great. All right. Our next problem is we want to prove that the product of 3 consecutive other integers is 315. We want to find this number, it's not proof. Okay. Now, there are a couple ways to do. Sometimes it's more difficult. If we want to try to solve a prime 3 prime integers, right? The one in the middle is the n. The one after that will be n plus 2 because different. Okay. The one before that n minus 2. So the product is going to be 315. Now it's very difficult to find the n. Okay, you can guess and try, but it takes times. Okay, that's not the way to solve the problem. Okay, you cannot easily solve an equation like that. You know, n is unknown. Okay, n is other number. So what we do is we do the other way around. We fact 315. Okay, 315, you add all 3 digits together, you get 9. So it's divisible by 9. So when you divide by 9, right? So you get 35 times 9. Then 35, is 5 times 7. Okay, so you solve the problem right away. Okay, so 3 plus 1 plus 5 is 9. It's divisible by 9. So that's why you divide by 9. Okay. Okay. So that's you try to see if it's divisible by 11, or if it's divisible by 3, or divisible by 9 first. Okay, also divisible by 5. Okay, this is very special one. Sometimes it's not divisible by 5. It's not easy to see that, and you just look at, yeah, try to see if you can find the small prime factors. Okay, so that's suggestion. Okay, so now we're going to do something else. Okay, similar to the one about, whether we want to prove whether, we want to prove that AB minus BA is divisible by 9 always. ABC minus CBA is divisible by 99. And here, ABC are digits. Okay, so it's either 2-digit numbers or 3-digit numbers. Right? Can you try and do the first one? Well, you can look at the examples, right? This is always true. Now let me check the examples. Okay, 1, 2 minus 2, 1. I don't know which one is first. It doesn't matter. Okay, 1, 2, 12 times minus 21 is going to be negative 9. It's divisible by 9. Okay, right? And you can also say 3, 2, 1 minus 1, 2, 3, and you what do you get, right? You will get some number divisible by 99. Okay. So 3, 2, 1 minus 1, 2, 3. Yeah, it's going to be 198, right? 198 is a double of the 99. Okay. So it's divisible by 99. But we have to prove it. Okay. We want to prove that this is true in general. Okay, how to prove the first fact? Okay, well, AB minus BA is going to be, AB is going to be 10A plus B, right? Separate them. BA is a 10B plus A, right? B is a 10th digit, A is unit digit. Then be careful, remove the parentheses, right? Then remove the parentheses, you get 10A plus B minus 10B minus A. So I get 10A minus A is 9A. B minus 10B would be negative 9B. Okay, so now there's a factor of 9 here. So you take a 9 out, you have an A minus B. So A minus B is another integer. Could be 1, could be negative 1, could be 2, negative 2, right? So clearly this is a divisible by 9, right? And for the same reason, you can do this as a problem. Okay. Right, so we got ABC minus CBA. We're given this, right? Let's do the same way. So 100A plus 10B plus C, right? Minus 100C plus 10B plus A. I think it's surprised B will be gone. Minus 100C minus 10B minus A, okay? So 10B is gone. 100A minus A is 99A. C minus negative C is minus 99C. Okay, so you take 99 out, you get A minus C, and clearly this is a divisible by 99. Right? Great. It's always a factor of 99 there. Okay, so we have a few problems here. We have to do a proof. We have to give a proof. Okay, when you give a proof, there's no answer here. We have a solution. When they have, if we are given problems, there's a difference between answer and the solutions. Solution consists of all the steps. Answer is just a number. Now, some problems here you don't have an answer. You have to give a solution. But some problems you can just give answer. But I wanted to show the proofs. I show the details. So when you do the homework, okay, do not just write down the number next to the problem, okay? But you can do that when you grade. Your parents probably keep the answer key from you, when you do the exercise, right? And so when you have to work on the separate notebook, write down the problem number and show all the necessary steps, like what I'm doing here. Then you put the answer maybe to the assignment sheet, so you can check that quickly later on. Okay, and if you find out your answer is wrong or you couldn't do the problem, and you spend a little bit more time later to redo the problems you made mistakes, or spend more time to think about. Sometimes you can get some hints from your parents. Okay, you have to spend time. Don't give up quickly. It takes about sometimes 5 minutes to 10 minutes, even 20 minutes. But gradually, if you can solve the problem, then your time spent on some difficult problem getting short and short. Okay. All right, so our next problem is still a proof, like show that the product of 3 consecutive integers is always divisible by 6. Now, how do we explain to that? How do we explain to that? Okay. Well, before you solve the problem, look at the example to see why this is always true. You can begin with 5 times 6 times 7. Yes, divisible by 6 because there's a 6 here. So I'm going to get away from 6. How about 7 times 9 times 8 times 9? Yeah, there's, then you have a factor of 2 from 8. You have a factor of 3 from 6. Actually, it contains 6 squared, not only just a 6, right? Because this is 7 times 2 squared, 2 cubed, and 3 squared. So you can get 2 times 7 times 6 squared there. So that's a 6 here. Okay. So how can I prove this fact? Okay. There are 3 situations here. If you randomly pick up 3 consecutive integers, so there's a possibility. You begin with a number divisible by 3. Okay. So it could be 3k plus 1, 3k plus 2. Okay. So you have a factor of 3 there. Okay. Right. So the product is going to be divisible by 3. Okay. Now, if you begin with 3k plus 1, then you have 3k plus 2, 3k plus 3. So this is a divisible by 3. This is divisible by 3. Now the product is divisible by 3. Okay. So the product, and then this is a divisible by 3. And this is also divisible by 3, right? And then if you begin with 3k plus 2, then you have 3k plus 3, 3k plus 4. And again, it's divisible by 3 because there is always there's always a number among the 3 consecutive integers, which is a factor of, which is divisible by 3, a multiple of 3. Now, why is divisible by 6? Because any 2 consecutive integers, one of them must be even. So one of them must be also divisible by 2. Okay, in any of this group, one integer must be even. Okay, sometimes 2 integers are even, sometimes 1 integer is even. Okay, and right. So yeah, there is at least 1 integer is even in these 3 groups, right? So the product is divisible by 3 and 2. Of course, then divisible by 6. Okay, combine them together, that's 6. That's how do we prove. Okay. So the first one, you have 3 cases here, or these cases, right? So just divide it into 3 cases and prove that in each case it's divisible by 3. But then on the other hand, one of the integers is divisible by 2. Must be even. Because even, odd, even, odd. It appears alternately. So take a look at the prime factorization of a 50 factorial. What is the power of a 5? Now, if you want to fact 50, right, you probably get 2 to the power p, and the 3 to the power q, and the next one is a 5 to the power r, and keep it going 7, blah blah blah, 10, n, but all those prime numbers, right? The next prime number is 11, and keep it going. Okay. So I wanted to find out that one. What is the prime fact? So please work on that if possible. 50 is 50 factorial is 1 times 2 times 3 times 4. Since we only consider 5, which one contains 5? 10, 15, 20, 25, 30, right? And then 35, 40, 45, and 50. Okay, so those integers, okay, those integers contains a factor 5. Okay, contains a factor 5. Right? Can you figure out how many of them right now? Collect them together. All right. So what you should know is there's two integers contain 5 squared. Okay. This is 25 and 50. Okay. That's very important. Okay. Okay. Then you will get, like, first of all, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have the plus 2. Okay. Right? Total, there'll be 12. There'll be 12. Now, think about in general. Suppose I give you a replace 50 factorial by 2022 factorial. Can you find a way to figure it out, to find out all the factors of 5? How about 2022? Yeah, this will be a challenging problem. For 50, I can list all of those numbers easily and count all of them, right? Because I can see them on the screen. But the 2022 is pretty large number, right? And is there any better way to solve this problem? Now, how many factors of 5 does it have? Right? So think about this problem. Yeah. Let me know if you find a quick way to solve it. Because sometimes you will see you're given such kind of problems. All right. So now let's look at this problem. What is the units digit of 7 to the 2022? 2022, this is a year of this is year, the current year, right? So usually they want to put the problems associated with the year, the current year, okay? There's a quick way to do. And how do we determine the units digit? Think about it. I'll give you an example, okay? 23 times 40, 45, right? As you can see that the units digit is only determined by 3 and 5, okay? The 10th digit do not make any contribution to the units digit. So you get 5 something. Okay, all you have to do is just pay attention to the units digit. Okay, because 3 times 5 is going to be 15. Okay, that's all you needed to know. Okay, 3 times 5 is 15. Okay, 15 is the units digit. Okay, so the units digit comes from the product of the units digit. Okay, so the units digit of the product comes from the product of the units digit. Okay, so I should say that the units digit of the product, okay, is determined by the product units digit. But the problem is that 7 to the power 2022 is just too many numbers. So we still cannot find the product of all the 7s, right? 7, just 7, right? 7 to the 2022 is 7 times 7 times 7, blah, 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 so many. 2022. So this number, according to the above statement, this number is the same as, if we want to find the units digit of this number, and this also have the same digit as 17 to the power 2022. Okay, so let's look at some pattern. Okay, let's look at some pattern. 7, and I only recorded the last digit of 7. Okay, the last digit is 7. 7 squared, okay? It's the last digit is 9, right? 7 cubed. So that would be 7 times 9, right? 63. So the last digit is 3. Then 7 to the 4th power. The last digit is 3 times 7 will be 1. Okay. Then it's 7 to the 5th. Its last digit is 7. So you will see that it is repeating. Okay. 7 to the 7th, the largest digit 3. 7 to the 8th, the largest digit is 1. Okay. So the last digit, the units digit, okay, change periodically. Okay. 2022, let's divide 2022 by 4. Okay. So that will be so the remainder is 2. So that means 2022 is going to be 505 times 4 plus 2. Okay, so at least you have a 505 blocks of 4 numbers and plus 2. So that means you have a 7931, right? 7931, and keep going. 7931, then you have a 79. Okay, so how many blocks here? 505, right? And then it's 79. So clearly the units digit is going to be 9. Okay, so the units digit of 7 to the 2022 is 9. Okay, we just the units digit, when the power increases, the units digit changes periodically, right? And 7931, 7931, 7931, right? Repeatedly. So repeatedly 505 times, but then you have 2 more left, right? In order to get 2022. So that's why 79. And stop there. 9 is the units digit. All right, great. So I'm going to ask you to do the next problem. What is the units digit of this product? All right, anyone have answers? What is the units digit? Just give me one number, units digit. I need one units digit, just one digit. Don't give me the product. Okay. So 1, 2, 3, 4, 5, 6, 7 times 4, 6, 6, right? 7, 2, 4. I think you only needed to consider the last digit, 4 times 7. And then for the same reason, the sum of the 2 numbers, the units digit of the sum is going to be the sum of all the units digit. So that's just 9. Okay. So that's why it's 28 plus 9, right? It's 37. So the units digit is 7. That's it. The units digit is 7. Okay, you don't need to worry about the tens digit, hundreds digit. Okay. Our next problem is we're going to consider the numbers expressed in the form 3n plus 4n. Okay. So if we consider the combination, okay, let's try to express the numbers in this form. Okay, the numbers in this form, I cannot clearly express. There's no solution. This is not, it's impossible, right? I cannot find, but even 2, I can make it 2 on it because n must be non-negative integers. I cannot do that. 3n plus 4n, yes, I can make it 3 because 3 times 1 plus 4 times 0, I can get 3. Okay, right? And 3n plus 4n can be written 3 times 0 plus 4 times 1. Yes, I can always write 4. Right? Expressed using, in this case, n equals 1, m equals 0. In this case, n equals 0, m equals 1. Now, how about 5? Am I able to get a 5 using this? I don't think so. We are not able to find the m and n positive non-negative integer. Okay. So let's continue. How about 6? I think for the 6, if I choose 2, I get 6, right? Okay. Then how about 7? 3 times 1 plus 4 times 1 equals 7. Yes, that's great. Okay, then how about 8? And you are surprised, I can always do that, right? How about 9? Nine is 3 times 3. It's 4 times 0 equals 9. So n should be equal to 3, m should be equal to 0. So I never have any problem right now, right? I can always express any integer larger than 5 as a combination of a 3 and 4, you know, a multiple of 3 and a multiple of 4. Right? And how about 10? 10 is 3 times 2 plus 4 times 1. N equals 2, m equals 1. So it's never have any, but it's harder to prove this is always true in general. Right? And yeah, and then you will see 11. It works. Okay, 3 times, yeah, how to get 11, right? 3 times 1 plus 4 times 2, I think. Yeah, that's 11. N equals 1, m equals 2. So you keep it going. I guarantee you, this always can be done. Okay, no matter how large is the number, start from here. So that's the phenomenon, right? We've discovered. Yeah. So we have a general theory, and what is you know, the theorem says that if 2 positive integers p and q has no common factor, the greatest integer which cannot be expressed in this form is p times q minus p minus q. Now this is not easy to prove, but that's a fact. So our p is 2, our q equals p is 3, q equals 4. So let's see, pq minus p minus q equals 3 times 4 minus 3 minus 4. Okay, so what is that number? 12 minus 3 is 9. It's a 5. So 5 will be the largest integer which cannot be expressed in this cannot be expressed as sum of the multiple 3 and the multiple 4. Okay, so I said that 5 is the greatest integer greatest possible integer, okay? Okay, which cannot be expressed as the sum of a multiple of 3 and a multiple of 4. Okay. Sometimes they will test you this. Okay, they give you another integer, maybe 7 or 5, and they wanted to. What happens when p equals 7? When p equals when q equals 5, and that doesn't matter, right? Then p times q minus p minus q equals 7 times 5 minus 7 minus 5. Okay, so so this is going to be 35 minus 5, 30, 30 minus 7, 23. So 23 cannot be expressed as the sum of all the 7 minus 5. But 24 is yes. Okay, 24 yeah, 24 we can probably can do that. Okay, so let's try to see if we can make it 24. Express 24. Yeah, so 24. Okay, so I'm going to 7n plus 5m. I want to get 24. Okay, what kind of mn you can choose? Yeah, solve this for positive integers. Right? Yeah, think about that. Are you able to figure it out? Yeah, find the non-negative integers so that you can have. All right, so here we do, right? 7 times 2 plus 5 times 2. Okay, so that is going to be 24. So it's guaranteed, but you cannot express 23 in this form. Okay, we guarantee. Okay, we cannot express 23 in this form. Okay. Yeah. All right. So our let me add one problem. So we want to know how many zeros are at the end of, okay, the end of how many zeros? The end of 24 factorial. Okay. So if we expand it, okay, 24 factorial is going to be 1 times 2 times 3 all the way, right, to 23 and 24, right? Can you figure it out? I'll give you 1/2 minute to think about. Anyone has answers? Okay, let me finish that. So in order to get 0 at the end, right, you have the key point is 2 times 5 is going to be 10. Only 2 times 5, you get 10. So you get 0 over there. So you just need to count how many factors of 2 there. So 24, if you have a 2 to the power p, and 5 to the power q, and then 7 to the power I, the prime factorization, right? And only these 2 factors contribute zeros at the end when you multiply this out, right? You remember, right? So that's called unity. But as you can see that just too many, usually, yeah, P is always greater than, yeah, here, this is a important fact. Q is always greater than, P is always greater than Q. You know why? Because there are too many even numbers. Then, yeah, 2 even numbers. So don't worry about the 2. There are enough 2s there. Just needed to count the how many 5. And you will see that here's a 5, here's a 10, here's 20, and that's it, 20, right? So you only have, so this implies Q is going to be 3, right? So 24 factorial is 2 to the power P, and 3Q, 5 cube, and 7. I think the 7 is going to be 7 square, why 7 square? There's a 7 cube also, 7, 14, and 21, right? Right? So 7, it also has a 7 cube. So, right? 1, 5, 15. Yeah, we have a 15 here. Yeah, 15. So 5, 10, 15, 20. So I'm sorry for that. So, yeah. So clearly, if we multiply them out, you're going to get 4 zeros at the end. So that is answer. Okay. Yeah. All right. So that's the end of the class, and we'll continue next Saturday.